Hi everyone. Hope you all are good. So we're going to start with lesson 3.4. We are working on grade principles of mathematics, grade 10 maths. The chapter we're working on is grade 3. The chapter is quadratic relations and the lessons we're going to start with is expanding quadratic expressions. So let's just start with the lesson. Okay. Okay, so here is the summary. Quadratic expressions can be expanded using the distributive property, then simplified by collecting the like terms. An area diagram or algebra tile can be used to show the relation between two binomial factors of degree 1 and their product. So to calculate the product of two binomials, use the distributive property twice. Okay, let's just start with the practice questions. Okay, here is the practice questions. Let's just start with question number A. M plus 3 times M plus 2. So you have to find the missing numbers. So which numbers are missing? Okay. So when you multiply M times M, it makes M square. That means here you are missing M square. That means here the missing term is M square. Then you have 3 times 2. So this one is 6. So it would be M square plus 2M plus 3M plus 6. So the correct option is M square and 6. Okay, let's just do the last one. 5M square, it would be negative. Here you have negative 3M, and then you have 3 times 2 is positive. Here you have 6. Okay, let's just start with question number 4. Expand and simplify. X plus 2 times X plus 5. So you have to use distributive property here. X plus 2 times X plus 5. First you have to multiply the x with everything inside this bracket, x times x plus 5. Then you have to do the same thing with here with 2 plus 2 times x plus 5. Got it? This is the distributive property you're going to apply here. X times x makes x square. X times 5 makes 5x. Same thing you have to do here. 2 times x makes 2x and 2 times 5 makes 10. So you have to collect the like terms. 2x plus 5x makes 7x. So it would be x square plus 7x plus 10, right? So the solution is x square plus 7x plus 10. Okay, the next one is expand and simplify. Question number 5. 5x plus 2 times x plus 2. Okay. Question number 5. 5x plus 2 times x plus 2. 5x plus 2 times x plus 2. So you have to do same thing here. You have to apply the distributive property. First you have to do 5x times x plus 2. Then you have to do 2 times x plus 2. So 5x times x is 5x square and 5x times 2 is 2 times 5 is 10x. Then you have 2 times x, it is 2x, and 2 times 2 is 4. So you have to collect the like terms. Like terms mean the one they have the same variable with same degree, like they are the like variables. So 10x plus 2x makes 12x. So it is 5x square plus 12x plus 4. Got it? Okay, the next one is, let's just do another part from question number 5, that is 7x minus 5 times x minus 3. 7x minus 5 times x minus 3. So you have to do the same thing. Just apply the distributive property. You have to do 7x times x minus 3 and minus 5 times x minus 3. So it is 7x times x is 7x square. Negative 3 times 7 is negative 21x. Then you have negative 5x, and negative 5 times negative 3 is plus 15. So you have to collect the like term. So it is 7x square minus 26x and plus 15. Got it? Okay. Okay, the next one is expand and simplify. Let's just do x plus 3 times x minus 3. It is question number 6. X plus 3 times x minus 3. So whenever you have x minus 3 times x plus 3 times x, whenever you have terms like this, a minus b, a plus b, you can write them as a square minus b square. You can simply write them with a difference of squares. It would be a square minus b square. So you can write them as x square and minus 3 square. So 3 square is 9. So it would be x square minus 9. Okay, hold on. That is the product of two binomials. Got it? Okay. Okay, the next one is 7x minus 5 times 7x plus 5. 7x 7x minus 5 times 7x plus 5. So you have to do the same thing, that is a minus b and a plus b. So you can write it as a square and minus b square. So that would be 49x square and minus 25. Got it? Okay, you can note down the solution. I'll wait for a while. Okay, the next one is question number 7. Expand and simplify x plus 1 whole square. Okay, question number 7. A x plus 1 whole square. So that means x plus 1 whole square means x plus 1 x plus 1. Got it? Like you do 4 times 4. Got it? So whenever you have something like this, you can do like a plus b whole square. You can write it as a square plus 2ab and plus b square. So let's suppose this is a and this is b. So you can write it as x square plus 2, a is x and b is 1, and plus b square, b is 1. So you can write it as x square plus 2x and plus 1. Whenever you have something like this, a plus b whole square, you can write them as a square plus b square, a square plus 2ab plus b square. Okay, the next one is 5y minus 2 square. So you do have to do the same thing. 5y minus 2 square. So let's suppose 5y is a and 2 is b. So you have to do 5y square plus 2 times a is 5y and b is negative 2, and plus b square, negative 2 square. Got it? So it would be 5 times 5 is 25y square, 5 times 5 is 25, plus minus minus, and 2 times 2 is 4, and 4 times 5 is 20y, and negative 2 square is 4. So it would be 25y square minus 20y plus 4. Got it? Just look at the signs carefully. Okay, you can note down the solution. I'll wait for a while. Okay, let's just start with question number 8. Write a simplified expression of the area of each figure. So this one is a rectangle. You know that the area of rectangle is length time width. So you are given the length and width. Length is 2m plus 3 and width is 4m minus 4. So you just have to calculate the area. Just do length time width. Basically, you have to multiply these expressions, right? Okay, 2m plus 3, 4m minus 4. Area equals, area of rectangle is equals length time width. Length is 2m plus 3 and 4m minus 4. Just solve them using distributive property. So 2m times, you have to do 2m times 4m minus 4 and plus 3 times 4m minus 4. 2 times 4 is 8m square, negative 4 times 2 is negative 8m, 3 times 4 is 12m, and negative 4 plus 3 is negative 12. So it would be 8m square, 12 minus 8 is 4m minus 12. Right? You have to do length time weight. So you just have to solve them. Okay, you can do question number 9 and 10 by yourself. Let's just look at the question number 11. Determine the equation of each parabola. So you are given with a parabola, you have to calculate the equation of the parabola. So let's just start with question number 11a. Okay. Okay, so let's just look at the zeros. So here is 4, and these are the x-intercept 4 and negative 2. And here is the y-intercept. Y-intercept is at negative 8, right? So let's just write down the x. The zeros are zeros at x equals negative 2 and 4. The zeros of the graph are zeros at x equals negative 2 and x equals 4. So the equation of the parabola looks like y equals a times x plus 2 and x minus 4. That is the equation in the factored form. Got it? And just look at the y-intercept. The y-intercept is this point, 0 and negative 8. The y-intercept of the equation is 0 and negative 8. Got it? So just use the y-intercept and find the calculate the a from this equation. Got it? So x is 0, y is negative 8. Y is negative 8 equals a times 0 plus 2 and 0 minus 4. So it would be negative 8 equals 2 times negative 4. Negative 8 equals negative 8. Here is a. Okay, you have a here. So a times negative 8. That means a equals 1. Got it? So the equation is y equals, just put 1 here, 1 times x plus 2 and x minus 4. Just multiply them. It is x square plus 2x minus 4x minus 8. So it would be x square minus 2x minus 8. That is the equation of the parabola. That is the equation of the parabola in the standard form, right? Okay, you can do the rest of the part by yourself. Okay, let's just do question number 14. Explain how do you know that the product will be quadratic when you expand 12x minus 7 times 5x plus 1. So how do we know? Because 12x minus 7 and 5x minus both the equation have x, when you multiply them they makes x square. Got it? So when the exponent is square, that means that is the equation of parabola. Got it? Okay, you can complete the rest of the lesson by yourself later today. I'm going to start 3.5, that is quadratic models using factored form. Quadratic models using factored form. Let me just write down the lesson name. Quadratic models using factored form. Okay, so let's just start with 3.5. Okay, here is a summary of the lesson. If a curve of good fit for data with a parabolic pattern passes through the horizontal axis, then the factored form of quadratic relation can be used to determine an algebraic model for the relationship. Let's just start with the practice questions. Okay, question number 4. A parabola passes through the points negative 4, 10, negative 3, 0, negative 2, negative 6, negative 1, negative 8, 0, negative 6, 1, 0, 2, 10. Determine an equation of parabola in factored form. Express your equation in standard form. Use a graphic calculator and okay. So just look at the zeros of the equation. Is 1 and 0. Got it? X is 1 and y is 0. And negative 3, 0. Got it? That means the zeros are at x equals 1 and x equals negative 3. Let me just do it on board. Question number 4. Okay, so zeros are at x equals 1 and x equals negative 3. So the equation in factored form is y equals a times x minus 1 and x plus 3. Right? Okay, now let's just look at the y-intercept. Y-intercept is 0 and negative 6. The y-intercept is 0 and negative 6. Got it? So just put this point in the equation and calculate the value of a. So it would be negative 6 equals a times 0 minus 1, 0 plus 3. So it would be negative 6 equals a times negative 3. Divide both sides, so a equals 2. Right? So the equation is y equals 2 times x minus 1, x plus 3. Okay, just solve the equation. So it would be 2 x times x is x square, negative 1x. Then you have plus 3x and minus 3. So it would be 2 times x square, 3 minus 1 is 2x plus 3. Let's just multiply by 2. So it is 2x square plus 4x and plus 3 times 2 is 6. So that is the equation of the in the standard form. That is the equation of the parabola in the standard form. Got it? Okay. Okay, let's just start with question. Let's just start with question 7. A hang glider was launched from a platform on the top of Niagara escarpment. The data describe the first 13 seconds of the flight. The values of the height are negative whenever the hang glider was below the top of the escarpment. Okay, what you have to do? Describe the height of the platform. Okay, describe the height of the platform. Determine an equation that models the height of the hang glider over the 13-second period. Determine the lowest height of the hang glider and when it occurred. Okay, determine the height of the platform. So that determine the height of the glider is same as the height of the platform at time 0. So the platform is 10-meter tall. Got it? That means the height of the platform is 10. When time is 0, the height is 10. So the height of the platform is 10. Okay, for the B, determine an equation that models the height of the hang glider over the 13 second. Okay, you have to write down the equation for this table. Okay, okay, so the equation is y equals 1.2x square minus 12x plus 10. Okay, let's just move on to next question. Okay, let's just do question number 11. Okay, examine the square dot pattern. How many dots are in the 20th diagram? Justify your answer. Okay, in diagram 1, you have 1, 2, 3, 4 dots, like 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, that is the square of 2 dots, then square of 4, then square of 6. Got it? So diagram 1 has side length of 2, diagram 2 has side length of 4, and diagram 3 has the side length of 6. That means the pattern shows every time they are increasing by 2n. Got it? When 2 times 2 is 4, then 2 times 3 is 6. They are increasing by 6. That is just the side length. Got it? So this is a square, so it would be 2n square. Got it? So you have to calculate for n equals 20. So it is 2 times 20 and then square. 2 times 20 is 40 and 40 square is 4 times 4 is 16, 1600. Got it? Okay, the next one is question number 12. Examine these three figures made of squares. Create a table of values to compare the figures number x with the area y. Draw figure 4 and 5 and add this data to your table. Then create a difference table to show that the relationship between the figure number and the area is quadratic. Determine an equation using your difference table. Work backward to determine the zeros. Verify that the zeros you determine correspond to your equation. What restriction must be placed on x to model this relationship accurately? Okay, so figure 1 you have 3. Figure 2 you have 1 2 3 4 5 6 7 8. For figure 3 you have 1 2 3 4 5 6 7 8 9 10 11 13 14 16. Okay, let me just make a table for the values x and y. Okay, figure 1 you have 3 squares. Figure 2 you have 8 squares. Okay, let me 3 have okay 15. So then in figure 4 you have 4 times, hold on, 1 2 3 1 2 3 4. That means the next one is 5. 5 times 5 is 25 minus 1. It would be then 24. Then for 5, 6 times 6 is 36, and 36 minus 1 is 35. Okay, that is the table of values with the next two values. For B, you have to create a difference table. Okay, let's just calculate their differences. First differences and the second differences. Okay, 8 minus 3 is 5, 15 minus 8 is 7, 24 minus 15 is 9, and 35 minus 24 is 11. Got it? Now let's just calculate the second differences. 7 minus 5 is 2, 9 minus 7 is 2, 11 minus 9 is 2. Okay, you can see the second difference is constant. Got it? That means that is a linear equation, right? Okay, the next one is you have to determine an equation for the relationship. You have to write down the equation. Okay, basically they are the squares of the values. You can see here you have 2, here you have 8. This is the square 3, this 8, this is 3 square minus 1 for 2. For 3 it is 4 square minus 1. You can calculate 16 minus 1, it is 15, isn't it? 9 minus 1 is 8. Got it? That means then the equation is y equals, here you have 3, here you have 4, x plus 1 whole square and minus 1. Got it? Okay, that is for the D, you have to write the equation. Got it? Okay, then you have to determine, okay, use your, for D you have to, using your difference table, work backward to determine the zeros. Okay, now you have to go back to calculate the zeros. Okay, you can use this equation to calculate the zeros. Got it? Start from here. For 1 it is 3, x and y. You can go to 0. When it is 0, x is 0, just put values in this equation and calculate 0. Minus 1 plus 1 is 0. When it is negative 1, you have to calculate the zeros. Negative 1 plus 1 0, that would be minus 1. When x equals negative 2, negative 2 plus 1 is minus 1 square is 1, 1 minus 1 is 0. When x equals negative 2, it would be 0. You can put the values in this equation and calculate the values. Got it? When you have x is negative 3, negative 3 plus 2 is negative 2, 4 minus 1, 3 it is. When negative 3, it is 3. Okay, here is the zeros. Got it? And for the E part, you have to verify the zeros. Okay, you have to verify. Just put the values in the equation. X is 0, y is 0. Yes, it is. Got it? Okay, just look at the 15. Examine the pattern of cube structure. Determine the number of cubes in the 15th model. Okay, just look at the pattern formed by the models. Model 2 and 3 look as though they could be broken into two equal square shaped prism parts. If one more cube were to be added to the corners of these two prism, basically they have just one less prism. Got it? You have to write down the equation for the determine the number in the 15th model. Which model in the pattern could be used build using 1249 cubes? Okay, you have to write down the equation first. 1 2 3 4 5. 1 2 3 4 5 6 7 8 9 10 11. You have to write down the equation for this relation. It would be the number of cubes in one of these squared prism is equal to 1 2 3 4 5. 1 2 3 16. 1 2 1 2 3 4 5 6. 1 2 3 6. 16. The equation is y equals 2x square minus 1. You have to calculate for 20. X equals 20, so it would be y equals 2 times 20 square minus 1. Got it? No, for the 15. 15 square is 450 minus 1. That means then they are 449 squares. Got it? That means in model 15 you have 449 cubes. Okay, for the B part you have to see determine which model in the pattern could you build using 1249 cubes. Okay, y equals 1249 equals 2x square minus 1. Just calculate the value of x. 1249 minus 1 equals 2x square. That would be 1248. Divide by 2. It would be 625 equals x square. So x equals 25. Got it? That means model 25 can be built using 1249 cubes. Got it? Okay, so we that's all for today. We are working on grade 10 math. So the lessons we have covered today are 3.4 and 3.5, and the lessons are expanding quadratic expressions and quadratic models using factored form. So please make sure before the next session you can complete all the test questions for the lessons we did today. So if you need more help with any of the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. So that's all for today. See you in the next session. Bye everyone.